All right, well, let's go ahead and get started. It's a little bit past 3. So again, this is informal. So feel free if you have questions to interrupt. And what we're going to do is we're just going to write some code and then we'll talk about things as they come up. So I'm going to share my screen. Okay, so I'm going to use VS Code this time because it's just a little easier for me. So you don't need to worry about this right now. You can, I would suggest for now using like REPL-IT or replit.com or whatever other similar thing you want to use, just a REPL in the browser. But we will, on the first day, the first couple of days, we'll get you set up so you can have an environment like this on your machines. But because I want to use different files, we're gonna run through some different examples today. I'm using this. So VS Code is just an editor, basically just a fancy text editor. And there's a terminal down here, so I can write files right here, create files, write code in those files, and then execute them here. So you don't need to worry about that, but just for context. Okay, so here's the thing we're going to be doing today. Create a key value store that allows for insertion and retrieval. So is that all clear? Does everyone understand?
Yeah.
Okay. So would you mind telling me what you understand from this very concise? Yeah.
You're gonna basically create an object and then have your key values and store data in them, right?
Yeah.
Am I off?
No, yeah. So we'll, does everyone else understand what we're doing?
Yes, so far. You're
Okay.
going to just create a key value and be able to put data in or take data or retrieve the data that you've already put in or put new data in it.
Okay. So I'm glad that everyone understands this, because this is very very light on information. So this is the kind of thing that you'll commonly encounter on the job, just like something's broke or we need to do this. But this really, there's not like what does a store mean?
Store data is somewhere where the data can sit, where it, I guess a lot of times we just do console logs when starting out, but an actual file or a memory location where the data can sit and be retrieved.
Okay, yeah. So are we talking about a file? Are we talking about storing in a file? Talking about storing it somewhere in memory? If we're storing it in memory, where in memory? What kind of structure are we using? So there's a whole bunch of questions that we can and should ask about probably all of these terms before we start working on anything. So if you get a task like, create a key value store, I mean, there are hundreds of questions we could ask before we would want to start writing any code, if this were, any kind of serious application. So just I just want to throw that out there. So don't just take vague information and then start coding. It's almost always a bad idea. All right, so a key value store. So just to speed things up, I'm gonna say that the store is basically, we're gonna create a list. So we're gonna create a store. This is kind of pseudo code, but we're gonna have a bunch of like blanks. We have some kind of object. In this case, it's going to be a list, a Python list. which is, like an array in JavaScript. And it's just going to have a bunch of slots. And these slots are going to they'll start out having no value or none. We'll probably use none as the null value. And then what we want to do is have a key value pair and then be able to insert and retrieve. So why would we ever want to do something like that potentially?
I guess to reuse information.
Yeah. Okay. So if we have a value, let's say an important value, like whatever this is, and we want to keep this around, we can put it in the store. But why? So we could just do this like this. We could have store, like updated store is, I'll copy this line. And just throw that in there like that, right? I mean, that could work, right? Well, it could work. So this could work, but then what happens if I want to retrieve my important value now? How do I retrieve it?
Either by the key or the value. So what is that? 0, 1, 2, 3, 4 would be the key or the value of my important value.
Yeah. Okay. So this is a good distinction to make. So if we have an array or a list and we have 0, 1, 2, 3, in some sense it's a key, but we talk about these things as being indexes or indices. So 0, 1, 2, 3, 4, this is an index in an array. We could, for example, if we wanted to, okay, so let me pause that real quick. So we have a store, and now we don't have a key, we just have a value. So we have an important value, and we've put that in there. So how do we retrieve it?
You'd reference the store.
Yeah. So how would you do that?
Not knowing syntax of Python at all.
Yeah.
Just store dot. I don't know. Store dot. My important value.
Yeah. So,
Store in brackets beside the store, like you're accessing its index.
okay. So let's not worry about the syntax, whether it's brackets or dots or whatever. So that, for our purposes now, that doesn't matter. But what I'm trying to get at is that if we don't have a key, the only way we can find this value is by iterating. So this is two-dimensional. So we are sitting here, on top of the page looking down, we can immediately see here's the thing we want. But imagine if this were a list with 5 billion entries or something like that. What you have to do, and the only way to do it, is you start at the beginning of the list and you check, is this the value that I'm looking for? If it's not, you move to the next one, and then you ask, is this the value that I'm looking for, right? So you have to check each one of these. You have to start at the beginning. If you want to be sure, you want to be absolutely sure that you're either you're finding it, or if you don't find it, that it's not in the list. So you have to start at the beginning and check every single one. So if there's 1 million items in this list and this value is the last one, how many checks do you have to do?
One less than 1 million.
Right. Yeah. So that's potentially a lot of checks. And if this is something that you're using all the time, that's potentially a lot of wasted energy. So one way to cut down on that particular waste, that particular kind of waste, is to add a key. So if we knew that the index of this was 0, 1, 2, 3, 4, if we knew that this was 4, we could write that down somewhere or even in our code, and we would have access to it, and then we could immediately access it, right? We get immediate. It doesn't matter if this list has 10 billion things in it. If we know the location, if we know the index, we can immediately grab it. So that's potentially a very useful thing to be able to do. Now the issue is, to a human, if I have, let's just say this is, I don't know, my password. So PAS 1, 2, 3, 4, right? So pass 1, 2, 3. This is my password, and I want to keep this somewhere and store it. I could remember something like, it's index 5,332,000, right? So that's what, every time I want to access my password, I have to remember that it's this index, which could be anything. But that's not very meaningful to humans. So what we can do is we can assign this a meaningful key, like password. And then do something like that. And now every time I want my password, I just type in password, and password is the key that will end up getting me this value. So this is basically, this one allows us to gain immediate access to a value, so we don't have to check every other thing in there. And 2, it's meaningful to me as a human. So those are the main benefits of something like that. Now, the issue is, since we're using a list as a store, we only have indices to work with. So 0, 1, 2, 3, 4, right? So it has to be an integer starting at 0 and going till however long the list is. So what's the problem there?
Indexes can change if something gets deleted out. So if you knew your password was, I mean, I'm fishing here, but if you knew your password was at index 4 and then you deleted 3, all of a sudden your password is now index 3.
Yes. So so it would depend on how you delete it. So if you just remove the value but left the list as it was, if you replaced, let's say, a meaningful value with like a null value, then the index wouldn't change. But if you truly removed it from the list, then yes, you're right, it would change. So that's one issue. But that wasn't exactly what I was getting at, although that is a good thing to think about. So so we have this store, and we want to use key values for insertion and retrieval. I know that a list for retrieval can only use an index. I also know that an index can only be an integer from 0 to whatever. My key, what is my key?
What you have highlighted, the key is password.
Yeah.
And the value is pass 1, 2, 3.
Yes. So what's the problem with this key in regards to what I'm trying to do here? Is what type of data is this?
It's a string.
Yeah, it's a string, and I need an integer. So we have a problem here where I want to use a string because that's meaningful to me, but my my choice of data structure forces me to use an integer. So that's a problem we're going to have to solve. We're somehow going to have to convert strings into integers, because integer is the only thing we can really use directly here. So we want to create a key value store that allows for insertion and retrieval. So we're going to use a list, a fixed size list. We want key values. And so we're going to have to convert keys to integers in order to insert the list. So that's our basic problem right now. So we're gonna have to make a list, a storage container, and we're gonna have to take in key value pairs, convert the keys into an integer that we can use in our list, and then insert that into the list. Okay, so that's the basic idea here. I'm gonna see, do the split screen. Okay. So how should we go about doing this? Just in general terms. You don't have to. Again, I'm not looking for specific syntax or anything.
If you want to, if you're talking about converting it to an integer, parse int, that's that comes to mind when I'm thinking about JavaScript. So you're gonna like change it into a integer.
Yeah.
Some
Okay.
some kind of built-in method.
So let's, before we start getting into those details, what, big picture, I mean, what am I trying to do here?
You're trying to make it easier to access items in a list.
Yeah. So should I write a function? I mean, what's like the largest unit of this problem right now?
Getting the variable set or defining the variables or defining the list.
Okay, I mean, yeah, so again, these are all things that we're gonna have to do. Okay, so what I'm trying to get at is we're gonna start by writing a function. So in Python, we start that with def, and this function is gonna be, we can call it KV store. You can maybe change the name later if you want. So this is what we're going to start with. So we're going to start with a function. And what is this function going to take in from the outside world, and what is it going to return? So these are the two questions you should ask. The first questions you should ask. Yeah.
Take in a string and output a integer.
Okay. Does anyone else have any thoughts? Agree, disagree?
Maybe 2 parameters, a key and a value.
Okay. Key and a value, that could be. What are we gonna do with this store?
Should take in the store and then the key value you're looking for, correct?
Yeah, so there's a few, so this is something that you want to think about when you're designing something. So, we could take in, I think at the least, we're probably gonna have to take in a key and a value, depending on how we design this. Maybe we won't go into detail, but there might be reasons why you want to accept this as a parameter, or this has to do with side effects. We talked about side effects a little bit last time, but for now, we'll just leave it out here. So let's work on creating a store first. So store. So if I want to create a list with a bunch of, let's just say, nuns in them, how do I do that? So I want to create a list that's 100. You don't have to give me the Python syntax. Just tell me in general how you would solve this problem. Even if you're thinking of JavaScript, that's fine. So we
You
want,
say you just want to create a list, is what you're saying?
yeah, that's let's say 100 elements long, and it's just filled with nuns.
Well, so that's the name of the list right there, store.
Sure.
And then you're gonna set it equal to, and then your empty array or your empty list.
Okay. So we have now an empty list. So now we want to
Do a loop, and for 100 repetitions or 100 iterations, and insert null or none in each time.
okay, good. Let's do 0 to 100. And so in Python, you don't need to memorize the syntax, but this is just a for loop. So this is basically gonna create kind of like a list of, 0, 1, 2, 3, 4, 5, 6, 7, and so on up to 99. And for each one of those integers, we're gonna want to insert a none into store. So store at I equals none. All right, so let's go ahead and print that as a sanity check here. And I'm going to run this here. You don't need to worry about how this works, but Python, and then file name. Okay. So there's a minor issue in that looks like this doesn't exist. Yeah, so list assignment index out of range. So what should we do now? Well, first thing I would do is I would go look something up on Google. So that's what we'll do. So there are lots and lots of ways that you can do this. Creating a list of whatever in Python. A few approaches to what you would do. So one, you should, as you're coding, you should constantly be looking stuff up online. I mean, that's basically, coding is basically looking stuff up online. We could start with an error message. That's oftentimes a good place to start. But in this case, this is going to be a little bit generic. And I think it would be better to look for the specific problem we're trying to solve here. So I'm going to do Python, create a list of something like that. Create an empty list in Python with certain size. So let's go here. Has anyone been to Stack Overflow? Do people find it helpful, or is it? I think
Very helpful.
Oh, very helpful. Okay, that's good. So
Mixed review.
How's that?
A mixed review.
Yeah. Okay. I think it's in the beginning. It's kind of I would say definitely very mixed. It can be overwhelming because you ask a question. Someone asks a question which is maybe similar to what you're doing. Maybe they're using an older version of Python and people are answering, then they're arguing in the answers. And then, so there's just a lot going on oftentimes. So here's, for people who aren't sure how this stuff works, Stack Overflow, you will end up using it all the time. So you might as well start becoming acquainted with it. So you can ask a question here, and then someone asks a question, and then people can answer it. The answer that the original poster approved gets a red check mark, and then other people can upvote the answers. So you ask a question. First thing you might want to do is scan for the green check mark, and then scan for answers with a lot of upvotes. So that's just a good initial kind of heuristic to use. And then you can start reading them. And learning how to ignore irrelevant information is part of the job. But here it looks like creating empty list, and we get this line. So none times 10. So that may work. Let's just copy paste that and see if it works. So if we want to do 100, we'll save that, and I'm going to run this. And it looks like that works. So, if this is good enough for us, then we can stop here. And I think for our purposes, this is fine. There are lots of ways we could do the same thing, but I think this will work. So we'll just go with this. Okay, so one problem solved. We now have our store created. Let's go back. So we've decided, for whatever reason, to keep this store out in the global namespace. And now we're going to have this function, and we decided that we're going to pass in a key and a value. And then this function is going to have to do a few things, right? So it's going to have to take in the key, which is going to be a string, let's say. And it's going to have to convert that into a number between 0 and 99, right? Does that make sense? Does that not make sense?
Makes sense so far.
Okay. So we have to, the problem is, so the kind of the core problem is we have a string. We have to turn that string into a number that's within the range of our store. So what happens if we turn our, let's use this example, password. So if we turn password into 700, what's going to happen?
It'll still be a string, won't it? Unless you tell it to be an integer.
Yeah, I'm going to go into Python REPL here, and I'm going to copy this code in. So this is just kind of like live coding. So if I want to do something quick, this is an easy way to do it. We'll get all this set up for you guys. Don't worry about that. So store. So I have store here. So now if I do store at 700, what's going to happen?
You get an error because it's out of range, or it's out of the store.
Yeah, I get index error. List index out of range, because there is no index 700, because there's only 100 things in here. So that's why we have to make sure that whatever integer we turn this into is within this range. Okay. So how should we do that?
Maybe default set the parameter, a default parameter maybe.
For the key, I'm gonna let me set this up. So k And I'm gonna pass in, let's do this. Or let's do. Okay, so here's my key value pair. Hi there. This is a bad example. So hi is the key. This is just the handle that I want to use as a human. And there is the actual value that I care about. So there is what I want to get stored in my store. So I call this function. I have hi here. What do I need to do with hi? You don't have to give me specific examples, but what is hi going to end up looking like?
And we have to assign to an index, isn't it? So you can refer back to it later.
Exactly. So hi is going to have to get transformed into a number between 0 and 99. So we kind of know, we know what our input is here, and we know kind of what our goal is. So now we have to figure out how to get there. So there's, again, lots and lots of ways we could potentially do that. I'm going to say we can actually grab. So again, this part is not really important, but you can actually grab. So these are Ascii values, these characters called Ascii. I forgot what the acronym actually stands for, but this is like a standard conversion between numbers and characters, at least in the, English kind of extended Latin character set. There's, I forget how many, 200 some characters. So you can actually get the value, the numerical equivalent for H and then for I. And you can do that in Python with board. So let me run this. So first letter, key 0. So I can actually, I'm calling this function with hi. I'm passing in the key, and I'm going to get the first character here. You can do this with Python. You can access the first character in a string using this syntax. And then I'm going to say print board first letter. And I'm going to run this. Oops. And I get 104.
104.
So H is 104. We do the same thing. I can just test it real quick. HI, so that makes sense, right? That in the alphabet is one right after the other, and it's 104, 105. Okay, so now I know how to convert a single character into a number, so that's good. So does anyone have any ideas what we should do next?
Are we at inserting that into the list yet?
Well, what would we insert and where at this point?
I think we're going to look for the first empty. I say empty, but if it's not occupied by something other than none, that's where we need to put that one.
Put what one?
Whatever's being passed in. If there was other things in this data structure already that you'd put inside of there, they wouldn't say none. So I guess we would need to kind of iterate through the data structure and find the first index that said none, and that's where we would put it.
Okay, so, but I still don't know what we're putting in and where. So I could just say, but at that point, we really don't even need a key, right? So I would just say, here's here's a list, and the first empty slot, I'm gonna put something in, and then the next time I get something, I'm gonna look for the first empty slot, which is gonna be the next thing, and I can just keep putting it in.
We need to get the value somehow pulled from there.
So we have the value being passed in.
We need to figure out where key is going to reference in the store.
Yes, so we
And
need to
100,
figure out,
104 and 105 are both out of range.
right. So not only are 104 and 105 both out of range, but they're both just characters in the key.
Yeah. If you put capital, it'll be a different number too.
Yeah. So we need to get one single value, which is going to represent this key. So how could we turn 104 and 105 into a single number?
Dictionary.
So yeah, that's fine. So we're actually not going to. We're kind of mimicking what a dictionary does right now. So we're not going to use an actual dictionary. But so I have 104 and 105. How can I take these two numbers and get one number? Because I mean, ultimately,
Add 'em.
yeah,
Add them together.
yeah. We could add them, we could multiply them, we could divide them,
Whatever.
we could do anything we want to them. Let's try adding them. So if I have a string and I pass it in and I want to convert each character into a number and then add them all together, how could I do that? Again, I don't need syntax, but just talk me through in human terms.
Each value.
So you're breaking up?
Oh, can you hear me now?
Yeah.
I was just saying you could iterate over the string and just add the value of each letter.
Yes. Good. So I'm going to create a variable here called sum chars. And I'm going to start it off at 0. And this is going to be our accumulated or summed value here. So I'm going to write a for loop. Again, lots of ways you could do this. We'll use a for loop for, let's do char in key. So this is a nice short way of doing this in Python and JavaScript. You'd have to be a little bit less direct, but we can actually, we don't have to like get the index and then access the index and so on. So we can get this value directly. So I'm gonna take sum of the characters is gonna be plus equals ord char. So I'm basically converting the character into a number. So each character I'm going to convert into a number, and then I'm just going to add them all one right after the other. So let's print some cars. And we get 209, which makes sense. So it looks like this works so far. Okay, so we're making progress. We're chipping away. So we've now converted this key into a single number, but a single number just so happens to be more than what we have here.
You could subtract and then it'd give you a number within the range instead of adding.
Yeah, we could
In this instance, but
yeah. Okay, so this is a good thing to think about. We're not doing lots of robust testing with edge cases and lots of other values, right? we can talk about that in a sec, but yeah, so there are certain, certain solutions can work for certain subsets of possible data, and then they won't work for others. Here, I think this will mostly work. There are definitely cases where it wouldn't, but we now have 209. So how do we, not just in this case, but in general, how could we, if we don't know what this value, so some cars could be anything at this point, any number. How do I take any number and make sure that it ends up between 0 and 100? I'm going to go into the Python interpreter. So the, let's see, 3 blah, blah, blah. So I can use the modulo or modulus, I always forget which, operator. And whatever number, oops, should probably use numbers here. Whatever number I give it, it's never going to be more than 100. Oh, interesting. So, yeah. So we can use this. We can use this to make sure that our number is within range here. So all right, so let's try printing. And we get 9 here. So 9 is in range, it's an acceptable value. So we can insert it. Does anyone know how I can insert in Python, if you happen to know?
I know it's brackets, and then inside the brackets, there's like a colon.
Okay. Yeah, so there can be a colon. So if I want to get like a range of this particular list, I can use a colon. Here, all we have to do actually is store and then at some characters. So in this case, it'll be 9 equals value. Right. So if I run this and then print, yeah, we'll do that. You can see there's our value in the 10th position, the index 9. Does that make sense? Does that not make sense?
It does, and to access it, you'd have to use its key, not its value.
Yes, exactly. So so that brings us to well, okay, so let's say maybe we need 2 functions now. We need something that inserts and something that retrieves, right? So let's try doing that. So what is the retrieve function going to look like?
It looked pretty similar, except where the store mod sum chars equals value line. Because you're
Okay.
still gonna have, you're gonna have still have to take a key and figure out what the number equivalent is.
Yeah. Okay, so good. Before we get into, specifics, so when I ask, the first thing you should think about when you're writing a function is what does it accept and what does it return? So what should key value retrieve accept? What should
Key,
it take in?
your
The
key,
Key. Okay, good. And what should it return?
the value.
Okay. I'll just put that right there. We don't have that defined yet. Okay. So yeah, we know that key value retrieve is going to accept a key and it's going to return a value. So what's just talk me through, not with any code or syntax, but talk me through what we're going to have to do to go from a key to a value.
You have to take the key, find the number equivalent to the letters, add them together, and then modulus by 100. So then you can find the position in the store of where your value is, and then return that value.
Okay. So I'm pretty much going to copy the whole thing here. Okay, so here we're going to get what's going to end up being, so actually, yeah. Sorry, one sec, my daughter's trying to sneak down here. Sorry about that. All right, so taking the key, I'm getting my converted value, and then I can access that. I should be able to access it. So store, let's do value. Does that look right? Does anyone have any? Might not be right. So if it's not, please. All right, so let's test it out and see if it works. So looks like we inserted it correctly. And then when we grabbed it, we were able to grab the value right there. So that's good. So this looks like it works. We haven't thoroughly tested it, but does anyone see any potential issues here?
If your key number ends up being the same as like the next key number you put in, you're going to write over your first value.
Yes, yeah, that's definitely, so that's called a hash collision. We're not going to worry about that right now, but yes, that is definitely something to worry about. But we're going to ignore it right now.
Also, we're not type checking. the parameter says key, but it doesn't make sure that it's a string that you're taking in.
Okay, good. Yeah. So it also, it doesn't do that. So we could add some checks to make sure. You can go ahead and do that. Yeah. So if, so how could we do that?
Well, I think it would probably just be a warning. Like if key is not the type of string, then you're gonna print this.
Okay. I think it's actually string. I'm just gonna return early. We won't worry about exceptions right now. So let's test this out. Okay, so we've written some code. We're pretty sure that it works right now. And now we're making changes to it. We're starting to make some changes. So this is something that happens very, very frequently. And this is one reason why we're not going to write real unit tests here, but this is one reason to write tests, because code is constantly being changed. And, you know, it's difficult to pick up every possible edge case. So it's a good idea to have a test suite. So I'm going to write another file here called hashing tests. And we'll talk about let's see. So you don't need to worry about imports, but I'm actually going to import the code here, and so I can use it here. Okay, so let's write some tests. So for hashing, I'm going to get rid of this. So I'll start off by just writing a simple test here. So for kv insert, so k kv insert we already have there. So what does this function return?
Returns a value. Actually, it doesn't return anything, does it?
Yeah. So how do you test a function that doesn't return anything? Yeah, it's a lot more difficult, which is one reason why you might want to avoid using global variables like this. But that's not the end of the world. So we could potentially adjust this, but we'll just leave it right here. So what I'm going to do is I'm going to return store. There's a slight trick here. Am I actually returning store? So the trick is that I'm actually returning a reference to store. So store, there are two kind of types of data in Python, two data types. There's the primitive data types, things like strings and integers and so on. And then there are reference types, things like dictionaries, lists, dictionary and object in JavaScript. And these things get passed around by reference, not by value. So there's only one copy of store. And even if we assign lots of different names to it and do stuff with it, we're really only operating at the end of the day on one single thing. So that's something to keep in mind. Don't worry too much about it now, but something to be aware of. So this now returns a value which we can check. So and how could we write a test for this? William, I don't think I've heard from you. So you don't have to give me syntax, but how could I possibly test?
So you could pass a key and a value and then print out what it returns, or you print out a updated store and just see if it put in your value.
Okay, yes. So I think the simplest possible test would be print updated store, and then we'll run and let's see, we got some other stuff going on. Comment those out. Right. Does anyone happen to know what the problem is here? This happened last week, if you happen to remember. So in Python, if you use a global variable inside a function, you have to mark it. Otherwise, it thinks you're, let me see. No, that is not. Yeah, why was that working before? Let's see here. Okay, so that is working. Try this. Now I'm a little confused. Why would that be none? Let's try this. Python actually tests. It's like it's not even.
It was working before we put that if statement, checking to whether or not it was a string. Everything was working. We put that in and we haven't ran it since. So there's something in the if statement that's hanging us up.
Okay, good. Good observation. So let's try running this again. And it looks like that works. So that's what we expect. So yeah, this is a very common thing. Something goes wrong, you don't know why. Usually something stupid, you have to play around with it. So okay, so we isolated the error. Thank you very much. So now we know that there's something wrong with this statement. So how could we troubleshoot this? So we've isolated the problem to here. How do we go about debugging this?
Google.
Yeah.
Yeah, we can definitely Google. So yeah, let's do that. Python, how to check parameter type. Checking arguments of Python. Type in is instance. So this, this is not the Pythonic way of doing this. There are some problems when you start having other kinds of classes, but it doesn't really matter right now. Okay. You type string. So one suggestion here is if type does not equal type str. Let's try that. So it looks like we're still having this weird issue. I'm
Can
gonna
you do it
say,
the other way instead of if not, equal. If it does equal, continue on. If it doesn't, then
yeah, okay. So if it is string, let's see.
so is that a string? Did we need to convert it to a?
So what I would suggest, Google definitely to be your first thing, but you can also just print. So let's see what we get here. So it is a string. So we're passing in a string. Let's see. So we can now, in the print statement, we can actually pass in a Boolean. Let's try that. This is true. So you can use this. And let's try this. So we'll test the not equals. It should be false here. So that's false. So now it looks like that works. So this is just Python specific thing. So if you understand kind of in general what you want to do, you can always look up the syntactic details. So don't sweat like memorizing every single list method or whatever on Python. That's you want to think about it from a more general perspective. You can always look up the details. All right. So how do we know? Okay, so let's go back to this test. So printing stuff and looking at it is good, but what if we have 20 tests? And what if this is just one part of our code and we have 500 other pieces of our code and they all have 20 tests? And we don't run these tests every time we change something. At a certain point, it becomes prohibitive to do it kind of this way. So you want to automate that a little bit. So
like a hard code, like you'll know what index high is supposed to be, so you're going to kind of hard code that, make sure it matches.
Okay, yeah. So we could do so there's actually an assert. So we could use print statements. We could also do assert. So this is a built-in Python, and if it will take in a Boolean. So we're going to test if something is true or false, basically, or if something equals something else. And if it is, then it's fine. But if it's false, then it's going to throw an exception, actually. So let's do updated store. So we know that the 9th index should be there, right? So let's run that test. Okay. So that passed, but sometimes you know, like a passing test, you know, was this just like a fluke? Is this even working? How do you know? Well, let's write a test that doesn't pass first. Okay, so we get an assertion error. So we know that this is working. Okay, so this is one test. This is kind of like a general, like, this is like the general use case that we imagine. What about, I mean, have we tested this piece of logic here?
Okay, stop.
Yeah, so we can test this here as well. So let's do type, something like that. And let's pass in a number. So how should we test this? What value are we expecting?
We're expecting a store to come back.
We're expecting it to return nothing.
Yes, exactly. We're returning, we could do this, but if we don't return something specifically, Python will automatically return none for us. So we can do is none. So there's only a single, none in Python is a single thing. So you can actually use is rather than equals. Just minor difference. So let's run this. So that also passes. So what you'd want to do is start building up some tests, and you want some edge cases. So something like very large strings, very small strings, an empty string. What does an empty string mean? Let's do assert. I'm just going to pass it in directly here. So, okay, insert. Anyone have any guesses if I pass in an empty string?
All NULL or
Undefined.
Okay, so maybe none.
or none.
Yeah. So undefined, yeah. So none is that value in Python. The value, I'll pass in another empty string. All right, so someone tell me about this error that I got.
So it's missing an argument. You have two parameters, so it's expecting two arguments. Is that what it's saying?
Yeah, so I just passed in this right here. A single argument, and my function requires two arguments. Okay, so I'm gonna pass in, I'll add this, I'll rerun it. Assertion error. So it's not none. So I might want to find out. I want to find out what this is going to be. So print.
And put an empty string in 0.
Yeah. Is that what we want? Is that okay? I mean, so one benefit of writing tests is that it forces you to think about what your code is actually doing and what you want it to do and so on. So no one knew what was going to happen if we passed in an empty string. So we could now that we've thought about it and written a test, we can, make an actual decision. What's a reasonable thing to do? Do we want 0? Do we want something else? It's any empty string is always going to be 0, basically. So we could add in another check here and say if you pass an empty string, you can't have an empty string as a key. So that might be a reasonable thing to do. We could also potentially accept it and then do something else. But the point is to think about it. Okay. So you can keep going with this and build lots of tests, account for lots of edge cases. And once you have all that set up, all you have to do is run your tests and you're sure that your code works. But there's some issues here. So this is going to run over. If you have to go, feel free. I'm going to try to zoom through the next little bit here. So this is okay. It works. We could make some tweaks to account for edge cases and so on, but let's just say that this works. Couple problems. One, we're repeating ourselves. That's always a bad thing. If you're repeating yourself, what should you do?
Don't repeat yourself.
Yeah, don't do it. Yeah. If you're repeating yourself, don't do that. Yeah. So the way you can avoid doing that, or the way you can solve the problem of repeating yourself is to refactor and pull all of that stuff out that's common into something else. So we can do
Like a helper function.
Yeah. So I'm going to take this and write a helper function. So def, let's do, what should we call this? So let's think about what this is doing first, and then we'll give it a name. So we're basically
Key to an integer.
Sorry?
Key to an integer.
Yeah. Yeah, let's do key.
Or a number.
To int. And what is that function going to look like? What is it going to accept and what is it going to return?
Accept the key, return an integer.
Yeah.
Accept the string, return an integer.
Let's do. I want to comment this out for now. Plop that in there. And I can keep that check here, comment this out. And now I can keep this name, so mod some chars. This might be a good time to refactor. This is maybe not the best name anymore, although it could be. So I'm gonna get rid of this now. What do I have to do to this function?
You have to call it.
I have to call it? and I'm
Oh,
at-
you called it there. Never mind.
There's,
You have to return something.
yes. Okay. Okay, so we're gonna turn that. We're gonna call this here. And I'll call this here. So we've just made a pretty big change to our code here. Our test should still work, right? Let me do. Let me do this here, sorry. So we're just gonna leave this as it is. Okay, so we ran our test and the test passed. So we didn't get any exceptions. So far we made a huge change to our code, but our tests kind of let us know immediately if we broke something or not. So that's a good sign. What's the downside now? I mean, so I'll just say, so one thing is we now have 3 functions and we're not testing this third function at all. The other thing this tells us is that on some level, we weren't really even directly testing whatever was in this third function. So all this code, in some sense, I mean, it was kind of indirectly being tested, but there's a lot of stuff happening in both of those functions. I mean, we're only really testing, the end result of lots of different things. So our functions maybe weren't the leanest. That's okay. So now let's go ahead and write some tests for k to int. So assert. I have to import this. Actually, we didn't even write any test for this, but we're gonna pretend that we did. K to. And that should be 9, right? So again, same logic applies here. You take a function, you test it, you test some, normal expected values, and then you try to test edge cases, try to make it break. Okay, so we'll just leave that as an exercise. So now we have these 3 functions. Okay, I'm gonna get rid of this. We'll do that there. Do we still have duplicated code? Is there anything? Okay, so let's start here. K to int. So someone tell me what's happening in K to int. Key to int.
It's just converting your key, which is a string, into its, what'd you say, ASC2
Yeah.
number?
ASCII, yeah.
ASCII.
ASCII.
So yeah, that's true. Here, so what we're doing is, I would say it's iterating over all the characters. It's summing up their ASCII values, and then getting the that sum mod 100. So we could break this up into further functions. So I would say, we could potentially take out this sum. So getting the sum. So I'm gonna pull this out into another function. do sum. Okay. And then I can do sum. Let's try run a test again. Looks like nothing broke so far. But you see, we've broken this down. So now our functions are getting more specific and fine-tuned. And they're all, again, we could potentially, I mean, you don't necessarily want to go nuts, but you could potentially break this down further. You could pull out a separate modulo function. So some of the benefits of this is it also makes it easier to test. So now we have another function that we can test, right? So before, again, we weren't directly testing this summing business. You don't want to get to the point where you're testing built-in functions, but the more you can test specific pieces of your code, the more confident you can be that everything is going to work. Whereas if you just have one giant function, yeah, you can test input values, and if it gets the output value, that's great. But almost always something is going to go wrong, and then where do you start looking? If you have everything chopped up into modular pieces, and all those pieces can be tested independently, if something breaks, it's much easier to zero in on exactly where the problem is occurring. So I'm gonna. I think that's probably roughly good. So classes. So we've started with. I guess we didn't. I didn't use separate files. Sorry, but we started with one function, then we added another function, and then we took those and broke them down now into 4. And we could further break this down. I think even pretty reasonably. We could break this down and probably turn it into 6 at least. So the point shouldn't be, your goal shouldn't be to make as many functions as possible, but functions should almost always just do one specific thing, if possible. All right, so classes. So we pretty much have, so in terms of how we would organize our code. So we have a file, so that's one kind of, a unit. It's a container, you can put stuff in it. So you have a file, you can have lots of files. And then we have functions. So function is another little container, you can put stuff in it. It's kind of isolated. So you have a bunch of these functions. And these functions are all kind of related, right? They all go together. You could use any of these independently. You could, if you wanted to, like, if you ever wanted to do this specific thing somewhere else in another program, you could borrow that and that would be fine. But it's often useful to take all of these independent functions and put them into another kind of package. And a class, at a very basic level, a class is just another way of organizing your code into another little package. So I'm not going to go into great depth here, but just to introduce it. By the way, does anyone have any experience with object orientation or using classes or anything like that? Okay, that is absolutely fine. So this is just the first exposure. I wouldn't expect to entirely get it the first time. So just let this be a first exposure and don't worry about it. So I'm going to create a class and I'm going to call it I'll just call it hasher, call it whatever you want. And I'm going to do, just as a first step, I'm just going to paste in all those functions that we wrote.
Are you done?
Close this. And this pretty much will work. So all I've done, I'm gonna have to make a few small adjustments, but basically all I've done is I've just grouped all these functions into a new namespace. So now instead of just calling k to sum, I have to call, hasher's k to sum. And then store here. Yeah, this could be a class variable. So I'm going to make some small adjustments that you don't really need to worry about, but they're just part of the boilerplate of making a class in Python. So by default, classes. So one thing, maybe the main thing, the most basic thing that classes do is just create a new namespace. So just like if I have, let me go somewhere else. If I can have a value here, so my val equals apple, whatever this is, right? I just have a value, and then if I want to use it, let's say print my, or okay, length. So print the length of my val. Run this file, and it's 5. Okay. But let's say I have a whole bunch of different. So I have an apple here. Let me just do this. Apple. Orange. Whatever. So I have a bunch of stuff, right? But so I could have just independent values and use these independent values as I need, but maybe, probably, these values have some other organization, and I can express that in code. So hypothetically, let's say this is my shopping list. So I can create a dictionary or an object, a dictionary in Python, and I can do basically just so in Python, keys have to be quoted. Minor difference. Commas. So now if I want to print the length of my shopping list's apple, shopping list apple, I get the same thing. So in some sense, this and this are the same. In another sense, I've created another container. So this apple, it may be the same apple, but for me, it's an item on my shopping list, and for you, it's an ingredient in a pie or whatever. So this is another container. I can still use this element anywhere, but this is a container. So a class is kind of like that. It's a container that organizes related things together. Another thing that a class does that a regular object, let's say, or a dictionary doesn't, is you can make this kind of generic. So this shopping list, there's one of them. So I created one shopping list and I specified everything on it. But let's say I go to the, grocery store every day. And let's say I get an apple and an orange, and I get some kind of soup. But, I don't always get clam chowder. So what I want to do is I want to create kind of like a form. like a shopping list form that I can fill out. So I can create, I have a form that's a shopping list, and then I can, every time I go to the store, I fill out a new form. So I create an instance of this shopping list class. So I'm going to create a shopping list class. So class. This is a convention in Python to capitalize classes. And what I'm going to do is you can actually pass stuff in. So when you create an instance of a class, by the way, if this doesn't make sense, just let it, this is just a first exposure. There's a method that implicitly gets called that's built into the class, whether you see it or not. And it will just set up the object. It will like, it's like filling out the form. So anything right here. So we want this soup value to be generic. You know, every time we fill out a new form, we can choose a different soup. So you can express that here. So def init. So this will look very weird. So this double underscore init. This is just a built-in Python thing. And every class method will just pass in self. You just have to do that. It's boilerplate. And what I care about is soup. So what I want to do is self dot apple equals apple. Don't worry about the syntax here. So notice that I've hard coded apple and orange. So let's say I always want apple and orange, but I've made soup dynamic. So when I create a new, let's say Tuesday shopping list, chowder. So on Tuesday, I'll print this out, print shopping list. Soup. So I've got clam chowder. So on Tuesday, my shopping list has soup, but on Friday, create a new instance, and I'll do, I hate tomato soup, but there you go. Print this out. Right, so the difference between, in this case, just creating a shopping list, I could of course create Tuesday shopping list, Friday shopping list, just as totally independent objects. But here, what I'm doing is I'm saying that, there's a thing called shopping list that I'm going to use, and I want to use it maybe a lot. So you can create lots of objects that are based on this template. And you can control what's in the template, and you can make some of it, constant, and some of it dynamic. So that's the basic idea of what a class can do. And you can put methods, and you can do all kinds of stuff, but at a basic level, this is kind of what it's for. Are there any questions about the shopping list? Again, if this makes no sense, that is absolutely fine. All right, so to wrap this up, I'm just gonna notionally kind of convert these functions into a class. So the first thing I'm going to do is just have to add self as the first parameter to all the class methods, so or instance methods. And self is the instance, so yeah, this gets a little strange, so don't worry about that right now. And then anytime I refer to another method here, I don't just call it because it belongs to the class now. So k to sum, it's not actually k to sum anymore. It's hasher's k to sum, or this instance of hasher's k to sum. So I have to refer to it self dot k to sum. Okay, and incidentally, I've kind of solved the problem of this global variable. It's not really global anymore. It's wrapped inside this class. So let's just make sure that this works real quick. So we're going to create an instance. And here, we don't need to pass anything in. So there's no, we could design this differently, but there's nothing here. And then I'm going to call this method. So my hasher dot insert there, and yeah, that returns it. So I'll print that. So this works the same as it did before, but now we have a kind of an object. It's a little bit more meaningful rather than just having a bunch of functions that we know are connected, but aren't really connected in the code. Now these methods are connected in the code, and we have a kind of a package. So don't worry about the syntactic details of classes in Python or JavaScript right now. If you know, feel free to start looking at it, but you don't like need to know that right now. But that's pretty much it. So are there any questions? Again, if you're confused by classes, do not worry. We'll get exposed to that. We'll do plenty of class stuff when, you know, class starts. Any questions or issues? All right, cool. Well, that's it. So if you have questions, feel free to ask in Slack. Slack's the best place. Otherwise, yeah, good luck. Keep at it. Keep playing around with stuff. The more you do now, the easier your life will be once we actually formally start.
Thanks, Chad.
All right.
Appreciate it.